Hello everybody, welcome. Hey, in this video we're going to talk about all the mysteries behind Voronoi diagrams and how you can handle them, all the stuff that comes up. Man, we're going to make it crystal clear. You're going to be rock solid, all right? So first of all, Voronoi diagram, what it is if you take a two-dimensional space like a map and you cut it up into individual units called cells, and they're non-overlapping, a tessellation is what that's called. Anyway, the big idea is that you've got all these little areas. They're called cells. Cells have boundaries. And inside of each of these cells is a special location called the cell point. And every other location within a cell is closer to its cell's point than it is to the cell point of its neighboring cell. So let's see an example that's really clear. Let's simplify this, right? So here I've got three cells, cell A, cell B, and cell C. Each of these cells has its cell point marked with an X. So point A here is the cell point of cell A. Point B is the cell point of cell B. And point C, well, that's the cell point of cell C. And each point within this cell, each location within this cell is closer to here than it is to A or to B. So like point M, for example, point M is going to be closer to C than it would be to A. And the reason that is because M is in the cell C. So it's going to be closer to point C than it is to the cell points of its neighboring cells. That's the big idea. That's half of what you got to know right there. So take a guess at this one and go ahead and write your answer in the comment section, right? Point K, is it closer to A or C or B, or can you not tell? So point K, what is it closer to? All right, we're going to talk about it. You ready? So because point K is in this cell, A, K is closer to A than it is to C, and it's also closer to A than it is to B. And the reason it is, again, is because K, the point K, resides in cell A. So therefore, it's closer to point A than it is to the cell points of its neighboring cells. That's half of what you got to know right there. All right, so now let's talk about the other half. This is where some of the math comes in, right? All right, let's take a look at this. Let's break this down. If you were to connect two cells points, right? Two neighboring cells points, so like A to C, if you connected that with a segment, right? The boundary line between those two cells would be the perpendicular bisector of that segment. So check this out. Here's what we're saying. From A to C, exactly halfway would be the boundary, right? So this is a midpoint right there. So the midpoint of A to C is going to be at the boundary, and it's going to make a 90-degree angle. So the distance from A to C is cut in half by the boundary, and it's cut in half at a 90-degree angle. And that's going to be super cool because whatever this slope is, the slope of the segment connecting A and C is going to be its negative reciprocal because they're perpendicular. And whatever the distance from A to this intersection is the same as the distance as that intersection is to C. So this is the midpoint. It cuts the segment in half, and it does it at a 90-degree angle. So that's the other really big idea. So those are our two key facts. The cell point, oh man, resides within a cell, and every location in that cell is closer to its cell's point than it is to the cell point of a neighboring cell. And if you make a line segment connecting two cell points, the boundary line is the perpendicular bisector of that segment. All right, so those are the two big ideas. Now let's see a couple of examples that make you use those ideas and practice some math. Right? So we're going to have to do some linear equations and perpendicular bisectors and all that kind of stuff. So let's break it down, all right? So this is one kind of example you're going to see. Here's what we're going to do. The very first thing we're going to do is we're going to find the slope of the boundary line, right? A couple ways you can do that. You can either count or you can use the formula. I'm going to count on this one because it's really nice and clean. I've got a nice graph. So rise over run are both 2. The slope is -1. Now remember, it's negative because it's going down from left to right. So I have a slope of the boundary line is -1. All right, so now we have to figure out what is the equation of the line that would connect C to A. And the way we're going to do that is we're going to use the negative reciprocal and the point that we're given, right? I'm going to plug all that stuff into y equals mx plus b, figure out the equation of the line. So since the boundary has a slope of -1, our slope is going to be +1, and we have the point 5, 2. So we're going to put 2 here, we're going to put 1 there, we're going to put 5 there, and then we're going to solve to find out the y-intercept of this line right here is -3. So our equation is y equals x minus 3. So somewhere on the line y equals x minus 3 lies point A, right? That's going to be perpendicular to the boundary. And yeah, so now where that line intersects the boundary is the midpoint. That's the midpoint right there. So here I can see what that midpoint is. I don't have to do anything like set the equations equal. Sometimes you have to, but let's go ahead and find that midpoint and then use that to see if we can figure out the coordinate, right? So the midpoint right here is 4, 1. Now, the midpoint formula is the sum of the x's divided by 2. That's the x coordinate. And if you add the y's, right, of the 2 points, the point over here that we don't know, we're pretending we don't know anyway, and this point, if you add those y's divided by 2, right, that's the midpoint. So we know that the midpoint is 4, 1. We know one point is 5, 2. So let's go ahead and take a look at the x's and the y's, separate them a little bit, and set up some formulas right here, right? So 5 plus the point I don't know divided by 2 is going to be equal to 4, right? See, 4 is the midpoint. So 5 plus this number over here, which we don't know, divided by 2 is going to be the midpoint, which is 4. And so if we solve this, multiply both sides by 2, we get 8. Subtract 5, x is 3. Let's do the same thing for the y, right? So the y coordinate we do know, 2, plus the coordinate we don't know, divided by 2 is going to be the midpoint. And we, of course, know that the midpoint coordinate for y is 1. So 2 plus the thing I don't know, divided by 2 equals 1. Let's go ahead and solve that. You get y equals 0. So that's how you're going to set it up if it's a little bit more complicated than this one, right? So you're going to find the equation. So you're going to find the slope of the boundary line. You're going to find the equation of the line that connects your known point with the one you've got to find. Then you're going to use the midpoint to figure out the exact coordinate. Pretty cool. A lot of math on there, so you got to be careful though, right? Now, the other situation is you need to find the boundary line, right? So here we have 4 cells. Well, we have 3, but C and D need to have a boundary line. So we're going to figure out how to find the equation of the boundary line that would separate cell C from cell D. Now, first thing we've got to keep in mind is that the boundary line is going to be the perpendicular bisector of C and D. So we're going to have to figure out the slope of C to D, right? So that slope is, of course, 0. All right, so we know that the line we're looking for is going to be perpendicular to 0, so it's going to be undefined, right? So the next thing we've got to figure out, though, is through which point does our boundary line cross? So it crosses at the midpoint. Remember, it's the perpendicular bisector, right? So I've got C and I've got D. I've got to find the midpoint of that because that's the point through which my boundary will cross. So my formula for midpoint, x1 plus x2 divided by 2, and then the sum of the y's divided by 2. So let's plug in the values we've got right here, right? So we have 5 plus 8, right? 5 plus 8 is 13 divided by 2, and then we have 2 plus 2. Divided by 2, which is 2. So 6.5, 2, that is going to be the point through which our line crosses, right? So now you're going to use y equals mx plus b. You're going to plug in 6.5 and 2 and the negative reciprocal of 0, and you're going to find the equation of the other line. Well, in this situation, the slope's undefined, right? The slope is going to be vertical. The negative reciprocal of 0 is undefined. You can't divide by 0. So x equals a number is a vertical line. So the number that x is going to equal is actually 6.5. So our equation is going to be x equals 6.5. Anyway, those are Voronoi diagrams. If you would like to have some practice problems and see some resources to help you practice the things you've learned today, check the link in the description, and I hope you have a great day. Thank you.